Today we start Fourier series of even function and odd function. Fourier series of even function and odd function. Fourier series of even function is defined as Fourier series of even function if f of minus x is equal to plus fx, then the function fx is said to be even function, and if f of minus x is equal to minus fx, then the function fx is said to be odd function. So this is definition of even function and odd function. Now we have to find Fourier series of even and odd function. Let fx is function defined in minus L to plus L. Let fx is any function defined in the interval minus L to plus L, and if fx is even function, then Fourier series of fx in minus L to L is given by fx is equal to a0 by 2 plus summation of an cos n pi x upon L, n running from 1 to infinity, where a0 is 2 by L integral 0 to L fx dx, and an is 2 by L integral 0 to L fx into cos n pi x upon L dx. This is Fourier series of even function where a0 is 2 upon L integration 0 to L fx dx, an is 2 upon L integration 0 to L fx into cos n pi x upon L dx, and the value of bn is equal to 0. This is formula for Fourier series of even function. The next is now we write formula for Fourier series of odd function. Let fx is odd function in minus L to L, then Fourier series of fx is given by fx is equal to summation of bn sin n pi x upon L, n running from 1 to infinity, where bn is 2 by L integration 0 to L fx into sin n pi x upon L dx. For odd function, the value of a0 and an equal to 0. This is Fourier series of even function. This is Fourier series of odd function. For even function, value of Bn is 0. For odd function, value of a0 is 0 and an is 0. For odd function, we have to find Bn only. For even function, we have to find a0 and an. So this is Fourier series of even and this is Fourier series of odd function. Now we take examples on Fourier series of even function and odd function. So first example, the first question, find Fourier series of fx is equal to mod of sin x in minus pi to pi. Answer. We have to find Fourier series of fx equal to mod x in the interval minus pi to pi. So here, if the interval is minus L to L, then check whether the function is even or odd. If the function is even, then write Fourier series of even function. If the function is odd, then write the formula for Fourier series of odd function. So here fx is mod of sin x. Now we find f of minus x. Replacing x by minus x, it is mod of sin of minus x. This is sin of minus theta is minus sin theta, and mod of minus sin x is mod of sin x, and it is same as fx. So here f of minus x is equal to fx, which implies that fx is even function. F of minus x is equal to fx, which implies that fx is even function. For even function, Bn is 0. For even function, Bn is 0 and Fourier series is given by, and Fourier series of fx is given by fx is equal to, Fourier series of even function fx is fx equal to a0 by 2 plus summation of an cos n pi x upon L, n running from 1 to infinity. It is same as a0 by 2 plus summation of n running from 1 to infinity an cos. Here given interval is minus pi to pi. Compare this interval with minus L to L. We get L equal to pi. So substitute L equal to pi. We get an into cos nx. Pi get cancelled. This is Fourier series of even function. Now we have to find Fourier coefficient a0 and an. a0 is 2 upon L integral 0 to L fx dx. This is a0. Now value of L is pi, so it is equal to 2 upon pi integration 0 to pi fx dx. But what is fx? Fx is mod of sin x, and This is 0, pi, 2 pi, 3 pi up to infinity. This is y is equal to fx is equal to mod of sin x. X axis, y axis. For the interval 0 to pi, the value of function fx equal to mod of sin x is positive. For this interval 0 to pi, mod of sin x is above x axis, that is fx is positive. Therefore, fx is same as sin x dx, because mod of sin x is equal to sin x for 0 less than x less than pi. Mod of sin x is sin x for 0 less than x less than pi. Now it is same as 2 upon pi. Integration of sin x is minus cos x, limits are 0 to pi. It is same as 2 upon pi. Take minus sign outside. Substitute upper limit cos pi minus cos 0. Minus 2 upon pi. Cos pi is minus 1. Cos 0 is 1. So minus 2 minus 2, that is 4 divided by pi. This is a0. Now we find an. The formula for an is the formula for an is 2 upon L integral 0 to L fx into sin fx into cos nx dx, but L equal to pi, so it is equal to 2 upon pi integration 0 to pi. In the interval 0 to pi, the given function fx is positive, therefore mod of sin x is plus sin x, cos nx as it is, multiply by dx. Take 2 inside, integral 0 to pi, 2 into sin x into cos nx dx. Now we have to solve this integration. So we use the formula 2 times sin a into cos b. This is angle A, this is angle B. 2 times sin a cos b is 0 to pi. 2 times sin a into cos b is sin a plus b, sin a plus b plus sin a minus b, bracket close dx. It is same as integration 1 upon pi, integral 0 to pi, take x outside, this is sin of n plus 1x, take minus x outside, minus sin n minus 1x dx, bracket close. We take, this is 1 minus n into x, sin of minus theta is minus sin theta. Now integral of sin is, integration of sin is minus cos n plus 1x upon coefficient of x, that is n plus 1, minus integration of sin is minus cos, it become plus cos n minus 1x upon n minus 1, limits are 0 to pi. It is same as 1 upon pi. Put upper limit x equal to pi, we get minus cos n plus 1 pi upon n plus 1 plus cos of n minus 1 pi upon n minus 1, minus lower limit, put x equal to 0. So cos 0 is 1, so minus 1 upon n plus 1 plus cos 0 is 1 upon n minus 1, bracket close. Now cos n plus 1 pi is, an is 1 upon pi minus cos n plus 1 pi is minus of minus 1 raised to n upon n plus 1 plus cos of n minus 1 pi is again minus of minus 1 raised to n upon n minus 1 minus, if we take minus inside we get 1 upon n plus 1 minus 1 upon n minus 1 bracket close. It is same as 1 upon pi. This is plus, we take minus 1 raised to n outside into bracket 1 upon n plus 1 minus 1 upon n minus 1 plus 1 upon n plus 1 minus 1 upon n plus 1 equal to 1 upon pi minus 1 raised to n into n minus 1 minus n minus 1 upon n square minus 1 plus n minus 1 minus n plus 1 upon n square minus 1 bracket close equal to 1 upon pi minus 1 raised to n plus minus n cancel minus 2 upon n square minus 1 plus minus 2 upon n square minus 1. It is same as 1 upon pi minus 1 raised to n into minus 4 upon n square minus 1. This is a n for n not equal to 1, because if we put n equal to 1 we get infinity. So for n equal to 1, a1 is, put n equal to 1 in this formula. So a1 is 2 upon pi integral 0 to pi sin x into cos x into dx. It is same as 1 upon pi integral 0 to pi 2 times sin x into cos x is sin 2x dx. It is same as 1 upon pi integral of sin 2x is minus cos 2x divided by 2, limits 0 to pi equal to minus 1 upon 2 pi put x equal to pi. So this is cos 2 pi is 1 minus x equal to 0. This is cos 0 is again 1, so it is 0. In this way we get the value of a0, an and a1. Now substitute a0, an in equation 1, we get required Fourier series. हुआ?